If you're looking forward to making a calculator in Minecraft and probably flex on your friends, you are in the right place. I'll not explain the reason for the two NOT gates here. We're gonna build addition. So addition is basically an XOR gate, because if you have the same input 0 0 or 1 1, the output will be 0. Well, with the case of 1 1, you get a carry. So let's build an XOR gate here for the primary output. Here's an XOR gate. But 1 plus 1 is actually 1 0 in binary. So now what we're gonna do is build an AND gate. So the reason I do the torches here is so I can direct the signal up, so there's space to do the AND gate. And then we'll do the idea. Okay, so AND gate, we need the redstone torches right here. We'll just place them down like this, and then we'll have a block here, and then we'll do this. So this is a carry right here. We're done with the carry. So have a look. So if we turn both of them on now, like the carry will work like it should. So this is already what we want it to be like, and then next step we're gonna deal with the carry. So just remember, in every single calculation cell there's a carry before it, so we need a carry input. So we're gonna just build like this, so it'll be a carry here, and then I'll do 2 blocks like this, and then we'll just copy what we did before. So 2 torches, the double NOT gate, so we can direct the signal upwards using the redstone torch. Like, this is some basic redstone technique. They're not really math techniques, but they just work. They're just how I'm gonna do stuff, because that'll be just easier. And then no matter what we do, the 2 carries will not be on at the same time. So that means we can just do an OR gate, which is basically connecting them up. We're doing it like this, so at this position we need a repeater, so the redstone doesn't connect. And then here's a torch, so I'll use a piston right here. Like, this is my idea of a piston redstone repeater. This basically means this piston is gonna push, so if I put redstone dust here, this torch will make it light. I don't want that to happen, so look at the piston, it will be pushed to the repeater. So we're just gonna connect up the signals like this, and also from here. Okay, so now I'm gonna talk about an optimizing technique. So if we have a redstone block here, then the thing is on, so we're gonna put a sticky piston right here. So we're gonna use this technique. We put a sticky piston here and the redstone block here. This will be the carry. So if this carry is on, then the carry is on. If this is off, it's off. So the idea is, if we can align them, well, we're gonna put redstone dust here. You will know the reason later. If we align it, that means we can just put the calculation cells one by one. If I do this, it will align. So if the next calculation cell has a piston right here, like the position of this cobblestone, it aligns, so we can just put it together. So now we're basically done with one of the calculation cells. A recap: 2 XOR gates for the additions with the input bits and the carry, and then AND gates for the carry indicator. The next step, we're gonna get structure blocks. So to do this, we have to use the command /give. We have to use structure blocks. Why? Because I don't want to take forever to build all the calculation cells. Okay, now I have a structure block. So the reason I use it is that I can copy and paste structures. So let's do it here. So now we're gonna change the coordinates of the structure block. I'm gonna change this one a bit. I'm gonna add a repeater just in case. Okay, so that's the carry and they will align. So you want the width to be 5 because if you look carefully, the width of the calculation cell is 5. And then we'll do the length. So y, the height, I'm not sure yet. I'm gonna do, okay, what is x? Is x the width? I'm not sure. So let's do 20. Yep. It seems like we didn't quite include everything yet. So if we look carefully. Oh, by the way, we need to make the y a bit higher, like 6, to actually include everything on top. So this looks right, just like what I did. And then we'll change the x to something like 34. Oh, that's a bit too much. So we're gonna turn it down to 30. Well, that includes every single bit of our structure. And let's name it anything we like. Just A colon A, save. Okay. The next, we'll just load the structure right here. We'll load it and then. Okay, so we have them connected. By the way, let's check that if it is connected. Yes, it is connected. We can break this structure block. And then we'll change this, the width of this to be 10. So it includes 2 of them. And then I'll click save, bang. Okay, so look, so now we copied the entire 2, so we can duplicate it to 4. We decide to put a structure block. This is a technique I use. I do it like 2 by 2, so I will do it less number of times. So, but why is this on? Okay, so I think I know the problem here. We didn't include this redstone dust, which means this one missing, so we had to include it. Bang, bang, bang. Okay, we included them. So now we're gonna break this one. Like before, we're gonna double it. So we changed the y to 7 because we realized our mistake, and then we changed this one to 20. So we double it each time. And next step, we just do the same thing. So now we have 8 bits. Seems everything's working like it should be.
Seems everything's working like it should be.
Ah, here. We're missing the redstone dust in this bit. So let's just fix them up. This is our full 8-bit calculator. Okay, so let's get back. Now we're done with addition, let's do subtraction. Yeah, let's do it in another place. I don't want to overwrite my addition calculator, it seems nice and cool. Subtraction. Do it here. But before we start subtraction, the idea of it is it's still an XOR gate because 1 minus 1, 0 minus 0 are zeros, and 1 minus 0 is a 1, but 0 minus 1 is a negative 1. But 0 minus 1 is a borrow, so after the borrow, the output should be 1, and then there will be a borrow. So the borrow is on if it is 0 and 1. We're gonna copy and paste this, and then we'll turn this with my magic power into subtraction. Okay, so from 20 we're gonna update that to 40, and then we'll actually name this property. Let's call it calc addition calc. Okay, let's do a save. We save the structure. We're gonna put it at another place. Okay, we're gonna load our calculator. calc addition calc. Load it, go. So this is an addition calculator. But maybe we made some mistakes. Well, no, we didn't make mistakes. We just left some of the torches turned on. We don't want them to be on. Let's turn this into subtraction. Let's have our first number subtract the second number. So the left one is the first number. So subtraction, the XOR gate is exactly the same, and we just turn the carry indicators to borrow indicators. So borrow is when the left one is 0 and the right one is 1. So it's basically not, left, and right. So we're gonna put a NOT gate for the left one on top here. But since there's a NOT gate here, not is a true. So we just have to connect the signal up, and we just have to get our blocks. Okay, so now we connect things up, and we also have to do it here, like with a borrow indicator. We have to connect things up. So, well, we don't want it to interfere with this redstone block, so we probably have to do it in another way. Okay, so what I think is I can just change this bit, and then we'll do a double repeater. We'll put a repeater here. That'll just work perfectly. And then we'll connect the signals like this. And make sure that this will not touch the redstone torch. So we just have to do this adjustment to every single block. Okay, now I've changed everything, and then now I can save the structure. So I'm gonna change this to save, and I'll change the name to, I'll just call it, yeah, subtraction. Oops, not caps lock. And that's a save. We'll save this to disk. Okay, so this is a subtraction calculator. It's basically the addition calculator except with some slight changes.